geobyte.
Let's take the another important problem. Try to read it clearly. It is asking like this. A body of mass m is projected with a speed u, making an angle 45 degrees with the ground. It is like this. It is like this. This is the ground. With respect to ground, the particle is projected at an angle 45 degrees with a velocity u. The angular momentum of the body about the point of projection at the highest point is expressed. You know, the body is moving in the free air, it is maintaining the projectile motion. This is the highest point. This is the highest point. At that highest point, let the height is capital H. Anyhow, the angular momentum of the body about the point of projection at the highest point is, at the highest point angular momentum is given root 2 mu cube by xg, the value of x is. Okay. For that, let us take the two component of velocities. Since the particle or body is moving with a velocity u at an angle 45 degrees with respect to ground, it is maintaining horizontal component of velocity u cos 45 degrees. This I can write as ux, and this is the vertical component of velocity uy equal to u sin 45 degrees. Since horizontal component of velocity remains same for any projectile motion, at the highest point also it is maintaining same horizontal component of velocity, that is u cos 45 degrees. That I can write as ux. Okay, component of velocity in the x direction. Then angular momentum, angular momentum is equal to angular momentum is equal to m into horizontal component of velocity into the maximum height traveled by the particle, because it is asking the angular momentum of the body about the point of projection at the highest point. M into u is nothing but ux is nothing but u cos 45 degrees, h no maximum height maintained by the projectile motion, u square sin square theta by 2g. Here theta itself is 45 degrees. Here theta is 45 degrees. Now we simplify this. Mu cos 45 is 1 by root 2. Of course, cos 45 and sin 45. Cos 45 degrees equal to sin 45 degrees. It is equal to 1 by root 2. 1 by root 2. Okay, into u square. Sin 45 is 1 by root 2. But it is sin square theta. It is whole square divided by 2g. Let us take another slide. The angular momentum is equal to mu by root 2 mu by root 2 into u square into 1 by root 2 whole square by 2g. Simplify this value. It is m u cube into 1 by 2 1 by 2 by 2g into root 2 root 2 is equal to m u cube by 4g into root 2 root 2. But what it is given? Root 2 mu cube. That means Let us multiply it with the root 2. Root 2 into mu cube divide with root 2. 4 into g into root 2 into root 2. 2. It is equal to root 2 mu cube by 8g. 8g. It is given root 2 mu cube by xg. It is equal to root 2 mu cube by xg. Therefore, x equal to how much? 8. The answer is 8. X value is 8. Understood clearly? Yes. Similarly, let us take the another important problem. Try to read it clearly. It is asking like this. Two disks of moment of inertia I1 4 kg meter square. Moment of inertia of the first disk I1 is 4 kg meter square and I2 for the second disk moment of inertia 2 kg meter square about their central axis and normal to their planes. Okay, rotating with angular speeds 10 radians per second and 4 radians per second. The first disk angular velocity 10 radians per second and the second disk angular velocity is 4 radians per second. Okay, respectively, are brought into contact face to face with their axis of rotation coincident. By the time the two disks are rotating, they are making contact between the two faces such that the axis of rotation for the both disks remain same. Then the loss in kinetic energy of the system in the process is dash in joules. What is the loss of kinetic energy? What is the loss of rotational kinetic energy? Because it is maintaining only rotational motion, which is in joules. For that, let us take the otherwise first let us connect the conservation of angular momentum principle for deciding the net angular velocity of the combined system. Applying the applying the applying the conservation of applying the conservation of angular momentum. So I1 omega 1 plus I2 omega 2 must be equal to I1 plus I2 multiplied by the combined system is maintaining angular velocity, let it be omega naught. So here it is I1 omega 1 plus I2 omega 2 is equal to I1 plus I2 into omega naught. I1 omega 4 into 10 plus I2 omega 2 2 into 4 is equal to 4 plus 2 into omega naught. It is 40 plus 8 is equal to 6 into omega naught. 48 is equal to 6 omega naught. From this I can decide that omega naught equal to 8 radians per second. So that is the combined system angular velocity. Now let us decide the initial rotational kinetic energy. Before both are made to contact, the initial rotational kinetic energy equal to half I1 omega 1 square plus half I2 omega 2 square. It is equal to half I1. I1 is 4 omega 1 square. Omega 1 is 10 square plus half I2. I2 is 2. Omega 2 is 4. 4 square. Simplify this value. It is equal to half into 400, 400 plus 16, 32, 32, 32 by 2. It is 216, right, joules. That is the initial rotational kinetic energy. Next, final rotational kinetic energy. Final rotational kinetic energy is equal to half I1 plus I2 into omega naught square. Half into I1 is 4 plus I2 2. Omega naught is 8 square. Simplify this value. It is 6 by 2. 6 by 2 is 3 into 864. Half I1 plus I2. I1 is 4. I2 is 8. So it is what 64 into 3. 64 into 3. 192. 192. 192 joules. 192 joules. Therefore, the loss of, he is asking the loss of kinetic energy. Let me write here. Loss of kinetic energy. Therefore, loss of kinetic energy equal to initial kinetic energy 216 minus final kinetic energy 196. You simplify this value for getting around 24 joules. That is the loss of kinetic energy. The answer is 24. I hope all of you clearly understood. Understood or not? Yes.
Geobyte.